let's talk a little bit about polynomials. So a polynomial is defined as a term or a finite sum of terms with only positive or zero integer exponents permitted on the variable. So I give you some examples of polynomials here, and then down at the table I give you some examples that are not polynomials. So notice they can't have variables in a denominator, they can't have negative exponents, and they also can't have any variables that are in radicals. Different types of polynomials include monomials, which are a single term, binomials, which are two terms, and then trinomials, which are three terms. A term is the product of a real number and one or more variables raised to powers. So for example, 2x squared y would be a term, and negative 5x would be a term. Essentially, they're just like pieces of your polynomial. Coefficients are the numbers that are out front of your terms. So this would be a coefficient of 2, and notice I'm going to say this is a coefficient of negative 5 because you always want to take the sign that's in front of it. Now we talked a little bit about this in Unit 9, but like terms have the same variables, and those variables are raised to the same power. So when you're adding polynomials, essentially what you're doing is looking for your like terms that you can put together. When adding, you can just drop parentheses that are around any of your polynomials. So I can add together, for example, 9y and negative 3y, which would give me a positive 6y. I can combine negative 7x, and I can combine, oh, this should be an x. I can combine positive 8x, which is going to give me a positive 1x, or just x. And then I can combine 15a and negative 8a, which is going to give me a positive 7a. Now, the order that you write your answer really doesn't matter. It's still going to be considered correct. There will be times where you have to distribute and add. Do make sure that the number that's outside the parentheses only gets distributed to the set of parentheses that's right beside it. So I would distribute the negative 4 here, making this negative 12xy squared. This would be negative 52xy. And then negative 4 times negative 5 is going to give me a positive 20x. Next, I'll distribute the positive 5 to this set of parentheses, which is going to give me 50xy. And then that's going to give me 30x. Same thing like before, you want to combine your like terms. So we can combine negative 52xy with positive 50xy. So I'm just going to bring this negative 12xy squared down. So this is going to be minus 2xy. Now I can combine positive 20x and positive 30x, which is going to give me a positive 50x. Now subtracting polynomials is a little bit different because essentially what you're doing is treating this as a negative that you are distributing to the entire set of parentheses that's behind it. So I'm going to bring down my first set of parentheses, or my polynomial that's in my first set of parentheses. And then again, I'm going to distribute a negative to everything here. So this is going to make this a positive 3y. It's going to make this middle term a negative 8x. And this is going to make this last term a positive 8a. Essentially, again, what's happening is you're just changing the signs of everything that's in that second set of parentheses. So now I can combine my like terms. So this would give me a positive 12y. Negative 7x and negative 8 is going to give me a negative 15x. And then 15 plus 8 is going to give me a positive 23y. Or excuse me, a positive 23a. Next, we need to talk about distributing and subtracting. So same thing here, you do want to distribute what's right outside the parentheses to everything inside the parentheses. The part that you have to be careful with is with this second number here. So the first one, you're distributing a 6. So this is going to be 60n squared minus 120m squared. And now I'm going to distribute the negative 8. So negative 8 times negative 3 is going to give me a positive 24m. And then negative 8 times positive 2 is going to give me a negative 16n. So again, notice I didn't just distribute an 8, I distributed a negative 8. So now I look down and see if I can combine any like terms, which I can't. So this right here is going to be my final answer. When multiplying polynomials, same thing like we just did with distributing. Just make sure that you pay attention to your rules of exponents. So keep in mind when you're multiplying exponents, you want to add them if they have like bases. So here would give you 15m squared n. I can't do anything with these exponents since the bases are not the same. The one in the middle is going to give you negative 12m to the 6. So notice I added the 2 and the 4. Then I'm going to just tack that in onto the n. And then the last one is going to give you 21m to the 3rd, because again, there's an understood 1 here. There is something called the full method that you can use when multiplying two binomials together. I never want students to really see this as a shortcut, because essentially all that you're doing is taking the first term here and distributing it to both those in the second, and then you're taking the second term here and distributing it to both of those in the second. So for example, I would start off by taking 7y, and I'm going to distribute to both of those in the second set of parentheses. So this is going to give me 28y squared. This is going to give me negative 35y. Next, I'm going to take the 3 and distribute it to both of those. So that's going to give me 12y, and that's going to give me negative 15. So then typically when you're doing this method, you can combine the two that are in the middle. So this is going to give you 28y squared. A negative 35 plus 12 is going to give me a negative 13y, and then minus 15. Same thing, I'm going to take 6a and distribute it to both of these two. So that's going to give me 6a times a is a squared plus 6ab. Then I'm going to take 5b and distribute it. So that's going to give me 5ab and then 5b squared. Next, I'm going to combine my two in the middle. So this is going to give me 6a squared plus 11ab plus 5b squared. And then the last one, I'm going to take 3x to the 3rd and distribute it to both of these two. So 3x to the 3rd times another 3x to the 3rd is going to give me 9x to the 6. Again, remember you're adding exponents. Distribute it to the last one is going to give me 6x to the 3rd y. I'm going to take negative 2 and distribute it here, which is going to give me negative 6x to the 3rd y. And then I'm going to take negative 2y times a positive 2y, which is going to give me negative 4y squared. Now in this case, you've got a positive 6x to the 3rd y and a negative 6x to the 3rd y. Those two are going to cancel each other. They're just going to give you 0. So you're going to be left with 9x to the 6 minus 4y squared. Special products are just like the last example that I showed you. You're still going to do the same thing, but in the future, in the next unit, or in Tier 3 actually, when you go to factor, it's going to be important for you to be able to recognize this. So notice everything in here is the same except one is subtraction and one is addition. So when you do the full method, or when you distribute with this one, notice what happens to your two inner terms. So this is going to give you plus 20x, that's going to give you minus 20x, and this is going to give you minus 16. So again, anytime it's the exact same except the signs are different, notice that those two cancel each other, so you're left with 25x squared minus 16. Be very careful with these. A lot of students try to take a shortcut and they try to raise each one of these to the second power, but this is not what that means. By definition, this in parentheses squared means 8z plus 3 times another 8z plus 3. So if you try to take a shortcut and raise each one to the second power, you're going to miss your middle term completely. So this is going to give us 64z squared. This is going to give us plus 24z. Notice this is going to give us the exact same thing. This is going to give us 24z as well. And then 3 times 3 is going to give us 9. So then our final answer would be 64z squared. We'll add our 24z's together, which is going to give 48z, and then plus 9. Same thing here. I would want to rewrite this as 5x minus 10 times another 5x minus 10. So 5x times 5x is 25x squared. 5x times negative 10 is negative 50x. Negative 10 times 5x is negative 50x. And then negative 10 times negative 10 is a positive 100. So then we would have 25x squared minus 100x plus 100. Now in terms of dividing a polynomial by a monomial, essentially what you're doing is breaking this apart into 3 different problems. So we would do 10x squared y to the third divided by 2x squared y minus 8x to the fourth y over 2x squared y, and then plus 22x to the third y to the fifth all over 2x squared y. So then we can use our quotient rule for each one of these. Keep in mind we're subtracting our exponents. So this is going to give us 5. The x squares will cancel each other, and then you'll be left with y squared here, minus 4. This is going to give us x squared when we subtract. The y's would cancel each other. And then plus 11, subtract our x's, just gives us x. Subtract our y's, gives us y to the fourth.